On to number 13. Number 13 is going to be kind of strange since we have a variable on both sides of the inequality, or one variable stuck inside the absolute value bars. So the approach I'd like to take is to start with a table of values. So I'm going to pick different values of n. I'm going to put the left side of the equation in this table. I'm going to put the right side of the equation table. And then I'm going to ask myself, is the left side less than, equal to, or greater than? Question mark. So the values, I'll just pick some values, some negative values. I'm going to plug these into the equation, and I'm going to put some positive values into the equation. So when I put -3 for n, this would be -3 minus 3, the absolute value of that. That would be the absolute value of -6, so that would be +6. When I put -3 in for n plus 1, -3 plus 1 is -2. So is the left side 6 less than, greater than, or equal to the right side -2? Well, that would be greater than. And I'm basically comparing these numbers right here. 6 is greater than -2. Let's try -2. Plug -2 into the left side. That would be the absolute value of -5. So 5. -2 plus 1 is -1. So 5 is greater than -1. Plug -1 in, be the absolute value of -4. And on the other side, -1 plus 1 is 0. And 4 is greater than 0. So far, my answer would not be n being -3, -2, -1, because I keep getting these greater than signs. I like to know when it's less than. But I do notice a pattern here. Now let me plug 0 in and then see if the pattern continues. 0 minus 3 is the absolute value of -3. That's 3. And 0 plus 1 would be a 1. And we get a greater than. So notice this pattern. 6, 5, 4, 3, and then -2, -1, 0, 1. I'm going to conjecture that this pattern continues. And then on the other side, the 1 plus 1, 2, 3, 4. So 2 equals 2. 3 is greater than. 1 is less than 3. And 0 is less than 4. So it looks like our answer of when is the left side less than the right side be for this value, and for this value we have less thans. So it looks like our answer is going to be n's have to be 2 or greater. So how do we do this algebraically? Well, we do it similar. We have two equations. We have n minus 3 is less than n plus 1. That's one of the equations. Then we have n minus 3 is greater than the opposite of n plus 1. Well, the reason why I wanted to make this table is because solving this first equation that we have here, equation number 1, equation number 2, solving this first one, we subtract n from both sides. We get -3 is less than 1. And then I can't really solve for n. There are no more n's. So that's just kind of strange. Like I said at the beginning, it gets strange because we have a variable on both sides where 1 is stuck inside the absolute value bars. Solving equation 2, we distribute the negative. We could add n to both sides. Add 3 to both sides. So we'd get 2n is greater than 2. So n is greater than 1. So that's helpful. Remember back here, at equal to 1, we have the two sides would be equal to each other. But anything greater than 1, all these values, n's greater than 1, gave true statements that we were looking for, the less thans. So we get a unique solution to absolute value inequality. We just have a graph like this. All n's that are greater than 1. Thanks for watching this video.